Welcome to QinetiQ's presentation on revolutionising air test and evaluation. I'm Cathy O'Carroll, Global Campaign Director for Integrated Test and Evaluation, and I'm joined today by two presenters, Chris Harvey and Andy Cunningham, who will introduce themselves later. We're all really pleased you've joined us here today, and through this brief we aim to share with you our vision for how air test and evaluation can and should be revolutionised and the benefits this will bring. Please do join us in the chat room afterwards with your questions when we will look to answer them. So to introduce myself, from 2014 to 2019, I was responsible for delivering and reshaping the long-term partnering agreement, a 25-year contract whereby QinetiQ maintains and operates 16 core sites across air, land and sea, delivering test and evaluation and training support services to both UK and international users. Now as Global Campaign Director for Integrated Test and Evaluation for QinetiQ, I'm responsible for understanding the needs of our customers across the globe for test and evaluation and shaping QinetiQ's strategy so that the T&E services we deliver are relevant to our customers and deliver value. Test and evaluation is the heart of QinetiQ's strategy to enable delivery of effective military capability generation and assurance to our customers. With over 15 years of delivering test and evaluation services to our customers through a number of strategic contracts, it's important to QinetiQ that we spend time thinking about our customers' needs for the future and how to deliver test and evaluation services that enable them to deliver their outcomes. The defence and security market is changing rapidly with a number of emerging themes, and these include an ever-changing global threat, increasing pace of technological advancement, increasing system complexity, but all of this is against a backdrop of continuing fiscal pressures. So why is this relevant to T&E? Well, threats are getting more complex and the speed at which they are doing so is accelerating. A growing number of global state and non-state-based threats make for a highly complex operational environment with threats covering the spectrum of drones to hypersonic missiles and cyber, with the average timescale to develop a new air platform being up to tens of years. Frequently, the threat a platform was designed to deal with has changed by the time that platform has come into service. And as the pace of the threat changing increases, the need to test and train against these threats similarly increases. The rate of upgrade of platforms will need to increase, similarly driving an increase in the need for testing. So in response to these threats, systems are getting more complex. We talk about systems of systems required to deliver an effective force. T&E is required to ensure these systems work effectively together and understand the vulnerabilities and risks between interfaces. As an example, many air forces around the world are developing intelligent autonomous systems to augment manned combat air platforms, acting as loyal wingmen to provide mission support roles such as the suppression of enemy air defence. Such vehicles will need to have a large degree of autonomy in how they prosecute their allocated mission to allow them to effectively support the manned element without overloading the pilots. As military testers, it is imperative that we consider the test and evaluation challenges that platforms such as these present and how we need to modernise T&E capabilities to meet these challenges. And thirdly, the pace of technological change is accelerating, which drives the need for T&E to enable technology to be brought into service faster. Increasingly, the commercial sector is driving innovation, with defence then adopting. This drives an increasing need for our customers to experiment with evolving technology to rapidly and safely create new capabilities for our customers. So before we talk about revolutionising test and evaluation, let's first just think about why we do test and evaluation. The purpose of test and evaluation is to generate objective and robust evidence to support decision-making, be that for options evaluation, procurement decisions, safety and performance certification, or quantifying operational effectiveness. We often express test and evaluation as a singular activity, but in fact it has two distinct and separate components. It has a test, an event that obtains raw data that can be used to measure something, and evaluation, a process where that raw data is analysed to aid decision making. It's in the evaluation where the value occurs. Evaluation is generally the relatively lower cost activity, but it does require human expertise. The testing is where the more significant costs lie in the form of specialist facilities and operators. So the questions we should be asking when we're doing test and evaluation is, what evidence do I need? And how can we provide more of it for less? How do we do this and revolutionise test and evaluation? And the challenge I would put is that we need to create a T&E enterprise that's optimised across the end-to-end military capability generation cycle, not stovepiped across organisations or programme phases, but an agile, digitally integrated T&E capability that enables experimentation, certification and qualification, and supports training, and can adapt to new needs. And this circle diagram will begin to explain that over the next couple of minutes. So let us think about 3 digital T&E themes. The first is establishing an evaluation digital thread, a single assured version of the truth, as shown around the outside of this circle. The digital thread would be populated from all T&E events. These would be outputs from experimentation, developmental, certification and qualification testing, training, into evolution of operational tactics and upgrades. So the digital thread would initially be populated with model-based design evidence being produced by developers of equipment. Live T&E would be generated where required to validate the models or test edge of the envelope scenarios where models are not able yet to predict. In-service outputs from training and operations would continue to populate the thread. This would provide a rich source of evidence to support decisions on things such as technology option selection, acceptance, tactics, and upgrade requirements. The digital thread would therefore need to be populated and accessible by developers, assessors, regulators, and customers. And this would enable the rich evidence chain that is created through a system's development and use to be fully utilised, ensuring that maximum value is obtained from the data available. Test data could be reused by different organisations for different purposes, supporting a test once, used many time mentality. And Chris Harvey shortly will unpack in further detail the opportunity that digital engineering brings to defence programmes. Secondly, as confidence in the performance of products comes increasingly from virtual means, there should be a fundamental rebalancing between live and model-derived evidence to enable faster, more cost-effective decision-making. Where a live test is required, the results should be fed back to validate the models. This would mean that models increasingly become more capable as a means of producing the evidence for decision-making, continually adjusting where live trials are required in the future. This requires through-life evaluation to be considered much earlier in development to generate and gather the evidence required, shifting left the evidence trail. As well as taking times out of programs through understanding and mitigating risk earlier, this would enable capability to be accepted into service faster and more cost-effectively. Thirdly, future T&E capability needs to integrate the right mix of T&E capabilities shown on the inside of this circle. So covering digital experimentation, test beds, fixed calibration capabilities such as T&E ranges, and also embracing deployable and onboard evaluation capabilities to support in-situ measurement in operational environments. This requires developers and assessors to work together to integrate the varying T&E capabilities in a federated way to provide an agile T&E capability able to deal with change in the future. And Andy Cunningham shortly will discuss range modernisation and embracing live, virtual and constructive capability to begin this journey of integrated, federated capability. At this point, I'm going to hand over to Chris Harvey, who's going to talk to us now more about digital test and evaluation and the benefits that can bring.
Good morning, I'm Chris Harvey. I joined QinetiQ in 2001 to Air Division. I originally joined a team that did air-to-ground targeting for fast combat aircraft. Back then, we typically thought of aircraft and systems as separate entities. We just bolted on a sensor pod onto the bottom of an aircraft. Nowadays, as Kathy has just told us, modern defence systems are becoming much more deeply integrated as a suite of systems and subsystems, and those systems are very closely coupled to deliver a capability. As such, the software and systems integration becomes a significantly key factor. Studies have shown that a majority of faults are introduced through requirements and the early design phases of a program. And it's also found that if you address these issues early, the cost to address and fix them is far less because you haven't built anything at that point. Typically, most faults are actually found through integration and system testings, where because you've actually got a real system, a real instantiation of your system, your hardware, the cost to address that challenge or bug can be 10 times the cost as if you'd found it in design. If you find these issues in service, you can be looking at hundreds, if not thousands of times the cost to fix. Now, typically, we often think of test and evaluation as a physical activity done at the end of a program, but significant volumes of evidence is generated throughout the life cycle of the program, as Kathy's just described. A lot of that evidence is driven through modelling and simulation, but due to stovepipes within organisations, that evidence is less often reused throughout a program. That itself can drive in additional work, time and cost to regenerate it. It's a kind of a generate once, use once, rather than a generate once, use many approach. Physical T&E can then often be used to address that gap in the evidence where we already had it, and once again, it's more expensive and it takes time in a program to do it physically. But with the advancement in computer technology, the fourth industrial revolution and the breakthrough of digital engineering, we're in a world where we have faster access to information which can accelerate the pace of decision making. We can perform significant investigation, experimentation and assessment using modelling and simulation actually on the engineering assets and models of those systems we're trying to integrate. So we're in a world where we can catch those bugs and issues far early and address it at a reduced cost. And as Kathy said, we're in a world where there's an opportunity for a rich collaboration between the customer, supplier, assurers and regulators, where everyone is focused on ensuring the right capability is provided to the warfighter at the speed of relevance. To bring about a transformational change in air T&E, we need a step change in how we collaborate between industry, suppliers, customers and regulators. And for this, we need a collaborative environment that enables rapid design evolution to allow those subsystems we're trying to integrate, the interactions between them, to be explored in a controlled manner. We also need a holistic view of the data and evidence that's used for evaluating and assuring our capabilities that are generated through a program, the digital thread that Kathy just spoke about, where this thread is accessible to stakeholders. So when we talk about a collaborative environment for rapid design evolution, what do we actually mean? What does it comprise of and what can we do with it? Its components are a portal or a user interface that someone, a user from an organisation, can go into and configure an experiment that enables your system to be investigated in some fashion. Within that, information is logged, displayed to the user, and the ultimate output of that simulation is then delivered to whoever requested it. This environment also captures a degree of metadata that has been created as part of that simulation, and that starts right at the beginning of your life cycle to populate your digital thread. And that metadata can then be used to establish a set of queries against to understand what capability you have at any point in time. Within that design evolution environment, there's a high-level systems architecture that links to system and subsystem models, which are those components which are owned and developed by collaborating organisations on a program or members of the supply chain. The architecture enables those links such that when the system is executed, the models are actually executed at the collaborating or the owner organisation's hardware. Effectively, it's a federated or distributed network simulation. And as such, there's minimal or no IP leakage between the parties. All of this is underpinned by a network that connects the supply chain and the partners. What this enables are system concepts and design iterations to be exercised against a set of requirements in an agile, on-demand manner, shortening timescales for both concept and design phase. Because the models are hosted and executed locally in a federated fashion, organisations retain control over their IP, minimising the need to conduct nugatory work to package it up and send it to a collaborating organisation. It also enables, as I said earlier, that metadata to be captured. So your digital thread, your digital evaluation thread, that single source of truth, is generated in a federated fashion. So, as I say, all parties now can see where we are within the development cycle, what evidence exists. In terms of the benefits to programs, because we've been able to exercise the system against that set of requirements and check that they're compliant or tweak and change accordingly, you've got greater confidence that the design meets the needs and before anything is actually built. This then also gives us reduced program cost and duration because you're able to exercise this in an on-demand approach. And you have a single view of the data as you go through, so you understand where you are at any one point in time. However, there are challenges and issues to realise this sort of collaborative environment. Firstly, culture and IP protection. How do you generate trust between partner organisations on a collaborative programme? Secondly, the handling of sensitive data across organisations. Typically, organisations are used to handling artefacts and sensitive data within their boundaries and acting on it within. However, on collaborative programmes, which we imagine is where the future will be, there is a question about how this works across company boundaries, as different organisations will be required to see that evidence in order to make decisions. As such, this will require a commercial framework of sorts to be developed, which will enable the engineering assets and data to be shared whilst respecting the sensitivities and IP of those contributing organisations. Finally, networks. There are many networks out there, but there's a big question about how you establish a network that organisations and the supplier base can effectively collaborate on and share engineering assets that operate at the appropriate security classification. The other element I discussed in the introduction around the evaluation digital thread would provide a single source of truth, which you can start early in the life cycle with outputs from modelling and simulation, and that then starts to build that evidence chain that you could use for certification, qualification and acceptance, but also you could use it for through-life upgrades. Having access to the thread can also encourage a richer collaboration between customer, supplier and assurer. It's not just the evidence and the artifacts that are there, but they can all be brought into an agreed process about how it's generated, how it's reviewed, and how they ultimately come up with a decision. That then, in turn, enhances how decisions are made and can build a significant amount of confidence in the quality of that evidence that's used for certification. In terms of test and evaluation, that evaluation thread can be used to drive out physical test time from the certification process. I said earlier that T&E is often considered the end of the process, but having the ability to query the evidence state at any point in time within a program, you can now start to do your assurance in a more progressive manner. In the case of an air platform, you could imagine that a platform could be flown sooner with a limited safety case once enough confidence in the modelling and simulation evidence has been reached. Because you've got that trail of evidence, it can come from any stage in the programme, from any collaborating organisation, and we understand its pedigree because that information has been logged through metadata on the digital thread. After that first limited flight, the platform safety case can then be expanded as the evidence from that physical act can now be entered onto the thread and is in turn used to validate or verify models, or is used to supplement areas of low confidence to address certification needs. What this is doing is changing the balance of where evidence is generated from live to modelling, much more of a mix, which is something that my colleague Andy Cunningham will elaborate on more.
Thanks, Chris. Good morning, ladies and gentlemen. My name's Andy Cunningham, and I am the Capability Development Lead within QinetiQ for the Long-Term Partnering Agreement. My focus is on future T&E capability requirements and ensuring that the LTPA remains relevant over the next 8 years and beyond and supports future military T&E needs. My background is aircraft test and evaluation, and previously, before coming into this role, I spent 4 years as the Innovation Director at the UK Defence Solutions Centre. During the next few minutes, I hope to outline some of the work we are doing on range modernisation to support future T&E needs. As Chris has highlighted, historically, model-based approaches have supported the initial phases of physical T&E. In a serial process, validating relatively simplistic models to reduce the amount of physical T&E. Future technologies, such as artificial intelligence and autonomy, mean this won't be practical. With new challenges, including the complexity of the systems being developed and deployed, and the new challenges associated with non-deterministic systems, will mean that the key drivers will become populating the digital twin and the associated digital thread with the required information. This will truly be a paradigm shift, and this will need to be constantly updated in near real time by information delivered through development, training and operations, truly blurring the lines between the traditional boundaries of development T&E, operational T&E, training and operations. This can already be seen in the increased demand to support end-user experimentation in operationally representative environments to support rapid, agile development of military capability. The model, i.e. the digital twin and the digital thread, will be the single truth. The traditional view of ranges will have to change to enable this vision. Ranges will be more than just the physical. They will enable and encompass the totality of the live virtual construct to support multiple requirements beyond just traditional certification and qualification. In 2019, the MOD and QinetiQ signed the RLTPA, a contract that will fundamentally change the traditional long-term partnering agreement. As part of this contract, the delivery moves from an availability model to an output model based on delivering defined events. In addition, this sees a significant investment in modernising the test and evaluation capability as a key enabler of supporting future defence capability. There are many elements to this, from infrastructure renewal to procurement of new sensors and systems. A key element of this is investment in our digital strategy. Our digital strategy can be summarised as digital transformation of the long-term partnering agreement to ensure that we support the customer by providing reliable, safe, secure and assured data at the right time to support customer capabilities and operations. Fundamentally, this means digitally connecting the information, ensuring it is tagged and stored in a way that is accessible when needed and supports the application of future analytics tools such as artificial intelligence and machine learning. These are reflected in 4 key focus areas: sensors and control, capture and storage, manipulation, evaluation and delivery of the data, and the connecting infrastructure, the supporting networks and the information systems that will connect all of this together. As we create a more digitally enabled T&E capability, this will support the model-based systems engineering that Chris has previously discussed. And through this, we believe this will support moving from mainly live to a greater proportion of virtual test and evaluation. This will involve blending live and virtual, enabled by the continual improvements in digital technology and augmented reality. This will be a progressive process and not an instantaneous jump. Over the coming years, Through the long-term partnering agreement, we aim to support this change and are already exploring how exercises such as the Carrier Strike Group generation exercises scheduled for this autumn could be developed in the future in this context. If you have any questions on the long-term partnering agreement and our implementation of our digital strategy, I look forward to answering them at the end. Thank you for taking the time to understand the future ambitions of the long-term partnering agreement, and I'll now hand back over to Kathy, who will wrap up our presentation.
Thank you, Andy and Chris. So hopefully over the last 30 minutes, we have described a vision for future test and evaluation. But this vision is not going to become a reality unless the community develops the right enablers to make this happen. Across the globe, defence engineering skills, including test and evaluation, are in short supply. Coupled with historically training personnel having taken many years, typically through building expertise and involvement in trials. The question as we go forward is, how do these skills need to change? This vision will not be fully realised through evolution of the skills we currently have. In addition to the current skills typically found in those involved in test and evaluation, we need to develop more digital skills based upon model-based systems engineering, simulation, and synthetics. There is much, though, we can learn from others in other sectors. In addition, while much investment has gone into T&E over many years in ranges and facilities, investment in the future needs to embrace creating the right digital environment through connectivity and data storage, but also data tagging and the tools to enable the data generated through T&E to be fully utilised and exploited for agile decision-making. We need to develop mobile and deployable T&E capabilities to provide flexible and agile capability to complement fixed capabilities such as ranges. Finally, there are two C's, culture and collaboration. Culture, we need to drive change now so as not to do the same as before with test and evaluation at the end of the programme. And collaboration, there needs to be a more collaborative approach to sharing data, but with ownership maintained. So what are the benefits of this digitally enabled test and evaluation enterprise we have talked around? Well, they're multiple. And at the beginning is improving and accelerating warfighting capability through increasing the pace of system development, certifications, and upgrades. Taking this approach increases platform operational availability. It reduces system-of-system integration risk, reduces cost through understanding risk earlier and avoiding rework. It provides understanding of operational capability and risk, including when acting as part of a coalition. And it enables improvements in the evolution of tactics. It really is an end-to-end capability. It increases understanding of what emerging technology can do, and it supports industrial export. So this really is a collaborative approach to future test and evaluation, enabled through a digitally enabled test and evaluation enterprise that brings multiple benefits to multiple stakeholders. And we really thank you for listening to this presentation. Now is the opportunity to utilise the chat room and to ask questions and let us have your comments, and we look forward to further discussion. Many thanks for your time.